There are situations where you want to be able to control the creation of objects. You want to have a measure of control of when objects are created and which objects get created. So that's where object factories come in. It's a way to control the creation of objects. So an object factory creates an object of some type without the user necessarily specifying the concrete implementation of the type. This is useful when you've got something like an interface and you've got lots of different types of concrete implementations. We've already seen an example of that. So let's say somebody goes into the bank and they have an option of lots of different types of bank accounts that they can have, but the bank might only allow them to have one or another type depending on their credit rating, for example. So the system will only decide what objects to create for them after they've entered all their details. So they enter the details, the system does some various checks. It does a check on their credit rating, and then eventually they get a bank account depending on their personal circumstances. So there are lots of situations like this within computer programs where the actual objects that get created for the client or for any kind of problem that needs to be solved within a computer program, where you don't know what's going to get created until after some kind of process has happened, and then only then does the system decide what objects to actually instantiate in the end. So that's where object factories come in. So the way you create an object factory is that you provide something called a static factory method. Usually one of the most popular names to call those methods is just a get instance method. So that's it's just a simple method to create objects, and get instance is a popular name for it. Users do not use the object's constructor. Access to the constructor is usually forbidden, so the instances are controlled, and you can only access them through your get instance method. The return type can be an interface, hiding the implementation detail. You can also return anything that you want. You can return the interface or any of the concrete types that implement the interface. The factory determines which implementation to use. So which implementation to use depends on your logic, depends on your code. So you've got a number of conditions in there, if-else statements, and all kinds of clever logic going on. And the factory in the end determines which of the objects to return an object for. The choice of implementation can be deferred to runtime. So looking to our bank account example, this is how you would implement it using a factory design method. So here you've got a bank account interface with the methods, the same methods we want to implement. What we've done is we've converted our abstract class into a factory class, and we're adding this method here called it's a static method called getInstance. You pass to it some parameters, and what it does, it returns a account type. So it returns something of type account and anything that might extend account. Okay, so you can return the account type and any of the concrete types defined here. So the free account or the overdraft account. Account factory instantiates an account. You determine which account to return from a key passed to guest instance. So this string could be the person's name, and int could be their age, for example. So this is one way in which you can create an object of type account. So you say account AC is equal to account factory dot get instance. Okay, so the reason you can do that is because get instance is a static method. It does not rely on an object being created in the first hand. So that's what static methods are. So you're sort of not using object-oriented programming here. You're not creating an object first before you can use the method. If you declare a method to be static, it means you can just use it. You don't have to create an object. And this is how you use it. You use the class name. Account factory is the class name, and you say dot, just call the method name if it's static. You can't do that if it's not static. And then you pass it whatever parameters that you want. So this is a simple way to create the object. We're telling it that we want a free bank account. And I guess within this method, there'll be some kind of an if-else statement. It'll say if the string passed is free, then return a free type bank account. If the string passed is overdraft, then return an overdraft type account. So you see how it's being decided at runtime what type of object to return. So yeah, so it could be, so what could be returned could be a free account or an overdraft or another implementation, depending on what string you actually pass to the factory method, to the get instance method. So here we have the potential to configure an application to use different concrete implementations at runtime. So it all gets decided at runtime depending on what conditions there are. This is the implementation of our factory class. Public abstract class account factory implements account just as normal. So what we're doing here, we've removed, notice, so this is our constructor, but notice how we've removed the public keyword from it. Therefore, it's no longer public, so it can't be instantiated from the outside world. So the key thing here is that notice how my factory is no longer public. I've removed the public keyword. So that means that it can only be accessed from within the class itself. We can't say something like we can't create a new type of object directly. We can only access it from within this get instance method. So we pass it the data we want, and here there's a simple if-else statement. If the information passed says free, then return a new free account. If account equals overdraft, if the information passed here is overdraft, then we return a new overdraft account. If none of these strings is passed, then throw a new illegal argument exception. So we're saying only allow one of these two bits of information to be passed through. So this is how you would implement an account factory. Another useful place where you might want to use object factories is to impose uniqueness. So if you've got a situation where you only want a particular type of object to be instantiated only once. So an example of that is a person's name. So we're saying here, if we've already got this particular name, then we don't want to allow this object to be created again, because we've already created an object for that particular person. Let's assume, so we've got this class here called name. It has a couple of strings, the person's first name, their last name. So this is before we actually convert it to a factory class. So this is how it's implemented originally. We've got a public constructor, first name, last name. You instantiate the values, and you're able to get the first name and get the last name. So what we want to do is convert this to a factory class. And the idea is that we want to guarantee that there's only one instance of name for each unique combination. So this is what our factory implementation of the previous example. We create a data structure. In this case, we created a map. A map usually has a key and value. Okay, so it's a key value pair. You look up the value based on the key. It's useful in this particular type of example. We've converted our constructor into private so that nobody can just come along and create an object without these checks. So we make the constructor private. So now that means that we can only access this constructor from within this class. It can't be accessed from outside of it. And then we declare our static factory method. So we give it the name, and now we pass, instead of passing the first name and the last name into the constructor, we pass those into this factory method. So we pass the first name, we pass the last name in here, and we start to do our checks. We've created a very simple way in which to create the key to add to the data structure. We're saying that a key is equal to, it's just a concatenation of the first name and the last name, so you're just adding the first name to the last name and we're creating the key that way. Obviously you probably want to do something a bit more complex than that in case rare situations where first name plus last name gives you the same key for a number of different names, but in most cases it should be fine. So we create our key, and then we say if the names data structure, so this here, so if the names data structure does not contain the key, that means that this object has not been created previously, then names put the key plus create a new name made up of the first name and the last name. So here's where we're calling our constructor, which here we made private. We created an object and we're adding it to the data structure. So now it's been added to the data structure. So then what you do is you return that object for the person who has created it to do something with it. So this is an example of a useful way where we want to use the factory design pattern. So we're imposing uniqueness. We're ensuring that you're only creating one object of each. So you only have unique objects. You don't have duplicate objects. You're not creating duplicate objects by mistake. So another place where you might want to use the factories is something called the singleton design pattern, where you only ever want to create one instance of any type of object. So you want to ensure that you're only ever returning one instance, and that same instance every single time, no matter how many times your class is being, your object is, somebody's trying to instantiate an object. So an example of that is a file system. So a dialog box will jump up and you'll be able to type in the name of the file that you want to save. So in that case, you don't want to create multiple objects of that type. You just want that one to jump up every single time. So you would declare a static final file system. You give it a name. Instance is equal to new file system. You declare your constructor to be private, so you can only access it from within the class in the same way. And then in your get instance factory method always returns instance. So this is my instance here, and you're always returning this instance every single time. Okay, so it's very simple. So that's a singleton design pattern. You don't allow somebody to create that object over and over and over again. You just allow them to create it once. So that's the singleton design pattern. So advantages of factories compared to constructors. So static factory methods can have more meaningful names. So we've used the get instance name, but you can call it anything else that you want. Whereas with constructors, you're always using the class name. Static factory methods are not required to create a new object each time they are invoked. Instances can be cached. If you use factory classes, essentially you're making your code more efficient. So you're the same object, so you're not clogging memory with the same object potentially over and over and over again. You're checking which objects are being created, and you ensure that the right objects are being returned to the person, and you not allow them to create new objects if it's not appropriate to create new objects. So you're imposing some kind of control, and it's a bit more efficient for memory and CPU resources. So instances can be cached. So static factory methods can return an object of any subtype of their return type. The return type of an instantiated object can be restricted to its interface. Implementation can be hidden and changed at runtime. Also, service provider frameworks can be extended with new implementations. So you can add as many implementations that you want, and it's not going to affect whoever's using your codes, because you can just add more implementations because the original code is returning an interface. Okay, so it's the same advantage of using interfaces that we talked about before. And then their book is item number 1, so it must be important. So probably a good idea to read more about factories here. So possible disadvantages: classes without public or protected constructors cannot be subclassed. So here it's asking, this is possibly a blessing, because we're trying to reduce the amount of tightly coupled inheritance as much as possible. So we'll talk about that a bit more when we talk about composition versus inheritance in part 3. Static factory methods are not readily distinguishable from other static methods, so there needs to be a way for the person that's using your class to know which method to use to instantiate the objects. Because if you've got a large class with lots of methods, some of them are static, some of them are non-static, sometimes it can be a bit confusing, and they can't tell immediately which method to use to create the object. So it needs to be clear, and so your documentation needs to be clear on how to create the objects. So an example of that is the collection static factories. So if you look at the collections framework, they use static methods quite a lot, so it can get a bit confusing. So you need to be careful when you're reading the documentation. So there's a tension between meaningful names and conveying the message that objects are being created. So obviously, in contrast, constructors stand out clearly in the API. Obviously, there's also a necessary level of indirection. So you're adding a bit more complexity to your code to create the objects. So it's a necessary thing. You can't do it any other way. So as a summary, don't provide constructors simply because they are the norm. So think about your code. Think about whether or not to allow the outside world to access your constructors or not. For a given class, consider whether the advantages of static factory methods are significant. If they are, then do not provide constructors and provide factory methods instead. If they are not, the advantages are not compelling, and then prefer constructors because they are the norm. So think about why and when to use factory methods. So think carefully whether or not it's appropriate for your code or not. So some cases it is. Some cases you do want the user to be able to access your constructor when they want to access it and be able to create as many objects as they want. So it just depends on the application being developed.